We have reached the end of the series. We saw two options to cut the pumping bill: where you operate and when you pump, using the tank as a battery. Today, the third, at what speed you pump. And here comes one of the most powerful and most misunderstood tools in pumping: the variable speed drive. First of all, the most important thing: where does the drive apply? Because it does not apply everywhere. If your pump carries water to an elevated tank, at a more or less fixed flow, the drive is not the answer. There, the right move is to select the pump well and schedule the pumping, as we saw in the previous episode. The drive shines in a different scenario, when demand makes the pressure change. The classic case: a building pumping directly to the apartments, or a booster pressurizing a zone of the network. There, where demand rises and falls all the time, is where the drive earns its place. The most common case is the constant pressure system. Look at this building. The pump delivers water directly to the apartments, and a sensor watches the pressure. When many open their taps, demand rises, the pressure tends to drop, and the drive speeds up the pump to hold it. When demand falls, overnight, the drive slows down. The pressure stays constant, stable, no matter how many people are using water. Instead of switching on and off or throttling a valve, the pump delivers exactly the flow being asked for, no more, no less. But the really interesting part is what happens to the energy when the pump slows down. Here come the Affinity Laws, and they are almost magic. When you change the speed of a centrifugal pump, three things change together. The flow changes in direct proportion to the speed, the head, with the square of the speed, and the power, watch this, with the cube of the speed. The cube. Look at the orange curve. If you drop the speed to 80%, the flow drops to 80, the head to 64, but the power drops to 51%. A small reduction in speed, an enormous reduction in energy. That is the magic of the drive. So why pay for a drive which is not cheap? For two solid reasons. The first, the energy saving we just saw, modulating the speed with demand. The second, holding constant pressure, which improves service and reduces bursts from pressure swings. Now, an important point, because many people get confused: the drive also starts the pump softly. But if that is all you need, a soft start, do not buy a drive. For that there is the soft starter, which costs much less. The drive is justified when you are going to modulate the speed continuously, all day long. And with this, we close the three options of the series, and something important: each one applies in its scenario. The first, where you operate. Keep the pump near its best efficiency, and above all, select it well. The second, when you pump. Use the elevated tank as a battery and take advantage of the time of use tariff. And the third, at what speed. The drive, where demand moves the pressure. Three tools, each for its problem. And so we close the series. The message is just one. In a pumped network, water barely costs anything. Moving it is the expensive part. And moving the same volume of water can cost a lot or a little, depending on how you operate, where, when, and at what speed. The same volume of water, a much smaller bill. Thanks for joining us in this series. We made it with the assistance of Claude Code. If you manage a network, subscribe to Transparent Blue Water.